A mentor of mine once said to me, skate to where you think the puck is going to be, not where it's already been. Unbeknownst to him, this advice shaped my decision to pursue the MD PhD, a career path that allows me to split my time between the hospital and the research lab. This dual perspective allows me to pursue projects I deeply care about, and today I'll share one of these projects with you. But in order for me to do that, I have to take you to the hospital and introduce you to David. David is a 7-year-old boy who was diagnosed with something called glioblastoma, which is a deadly type of brain tumor, so deadly, in fact, that the 5-year survival is less than 5%. The most important aspect of David's care is surgery. And surgeons will try to remove as much of the brain tumor as possible, but they face a very difficult challenge: identifying the margin between brain tumor and normal brain. Now, surgeons don't want to cut too much because they'll risk damaging healthy brain tissue, leading to neurological deficits, but they also don't want to cut too little because they'll leave behind cancer cells that'll grow back very fast. Currently, there are no tools or technologies that exist that allow surgeons to delineate brain tumor and normal brain in real time. As a result of this, David will likely return to the hospital within 8 months when his tumor inevitably returns, and will only have 15 months after that. What you're feeling after I just said that was what motivated us to help children like David. In the research lab, we asked, how can we help surgeons improve tumor removal? And our answer is the intelligent knife, or iKnife for short. It builds on a tool surgeons already use called an electrocautery. Surgeons use this tool to remove tumor by burning it. What the iKnife is the simple addition of something called a mass spectrometer. The reason why this was done was because when you burn tissue, there's smoke that's released. And that smoke actually contains information about the tissue that you just burned. The iKnife is able to capture the smoke, analyze it with said mass spectrometer, and create a chemical fingerprint of the tissue that was just burned. We then developed an AI algorithm to tell us whether this fingerprint belongs to tumor or normal. We can then provide surgeons a red circle if it was tumor, and a blue circle if it was normal brain, like the one you see up there. In fact, we found that we can do this to an accuracy of almost 96%. 96%. The only thing left for us to do is to implement this in the OR, and once we do that, we believe we will provide surgeons a precise way to remove tumors, decreasing the number of repeat surgeries and the risks associated with each of those surgeries. But more importantly, we provide children like David with not just a few extra months, but a fighting chance at life. Now, I don't know if you've noticed, but David has his skates laced up because he and I both know where this puck is going to be. Thank you so much.